for your presentation right now.
Yes, thank you for your introduction. My name is Kasimir. I'm from the Technical University, and this study has been conducted together with Siemens Real Estate. As already mentioned, the topic is design optimization approach, comparing multi-criterial variants using BIM in early design stages. So as a short introduction and the necessity of holistic sustainability for buildings, I put some numbers here, what the built environment means as an industry globally. So 19% of the global GDP is responsible, the built environment is responsible for, as well as 35% of the global warming potential, or 42% of the total energy demand. But at the same time, it's also responsible for 50% of the resource demand, and 90% of the time people spend indoors. So these numbers should highlight that a holistic consideration of multiple sustainability criteria are necessary for building design, especially also in early design stages. I focused as a multi-criterial variant analysis. I first focused on life cycle assessment, so on environmental impacts of buildings, especially on embodied carbon, so on the global warming potential of embodied materials. And due to the norms, life cycle assessment, as a short introduction, has those four parts: goal and scope definition. Usually that's standardized by norms or green building certification systems. We have an impact assessment, which usually have standardized databases. In my case, as I'm from Germany, we have a public LCA database called Ökobaudat. But the big potential for integrating the BIM method to that LCA methodology is mainly the inventory analysis, specifically using BIM for an automated bill of quantities, but also optimizing the design in an early design stage, and using design decision support for variant analysis. In the last step of the LCA, you usually interpret your defined goal and scope. You interpret your results. And also here, there's a big potential of visualizing your results in a 3D model with semantic information. So in my first step, in the paper I published in this conference, I did a literature analysis, first focusing on 59 papers in the field of LCA and BIM, but always checking about if they also have a multi-criterial approach. And finally, I was filtering these 59 papers and came up with an analysis of 25 recent papers, so from the last 3 years, which were focusing on the integration process of BIM and lifecycle assessment. And as you can see here, I did set up some criteria. So basically, first about BIM. So if they were using which open BIM or closed BIM approach, which exchange files they used, and also which LODs were used for the case studies and the papers or the processes, as well as the goal and scope of the lifecycle assessment, which databases they used, but of course also about what type of integration workflow was used in these papers. To sum up, I came up with that research gap and the general goal of developing a method that enables partially or fully automated calculation of the embodied energy, so life cycle assessment, using the open BIM approach, specifically using the IFC format, for multi-criterion variant analysis, So I don't only want to focus on embodied energy, but implement it in a framework that enables also other criteria to be analyzed to support design decisions process and focusing on the early design phases. To be added to this research gap, I also want to mention that uncertain information, which usually come up in early design phases, shall be handled by ranges of design options, especially if there are no information, then the possible potential range of design options should be implemented in a standard component database, which also includes design variants using domain knowledge. So I proposed the following methodology, and I'm starting with a general framework. So as already mentioned, I'm using BIM models. So I'm exporting from the authoring tool an IFC file. And at the same time, my other input for the conducted analysis is this standard component database in the SQL format. And my first step is first to map the IFC elements to the standard component database. How I will do that, I will explain later on. Second step is to conduct, as previously shown, the necessary quantity takeoff for further calculations. And then in the next step, when I mapped the IFC elements to the standard component database and have all bill of quantities, I'm doing the calculations. So first I'm focusing on the lifecycle assessment, and the second step, I will add other criteria such as cost. To finish then this whole framework, I want to visualize the results and conduct a design decision support, analyzing different variants, and finally select one variant, and in the end also to communicate that change or selected variants back to the BIM authoring tool using BCF. In the next two slides, I'm focusing or presenting the standard component database and the mapping algorithm. So the proposed standard component database is first has different entities and with different attributes. I'm not going to go into detail, but of course we have different components with which consist of different elements. So for example, the component could be an exterior wall, and elements could be insulation layers or finishes, as well as the load-bearing material and others. These elements consist of different material categories, especially in early design phases. We don't know yet the exact material, but usually already material categories. So we wouldn't know the exact of an exterior wall. It could be the material concrete, but we don't know specifically which type or classification of concrete it is. That's why we have this entity in the middle before we have the final material option, which is then specific material, which is known then. And these entities are also connected to external databases. In this case, I added external databases, for example, exchange rates of certain materials for different layers. It's also a German source. How often do you exchange which layer or you replace them? As well as the LCA database, so the environmental data. In this case, as I already mentioned, it's Ökobaudat, and extended that to with end-of-life scenario, which is not always given. In my study, I'm focusing on global warming potential, but of course, these impact categories can be extended. Now coming to the automated mapping method. So on the left side, we can see the IFC model, and on the right side, we can see the standard component database. The first step would be filtering due to classification. In my case, I again used the German norms, and we have according to the norms, different cost groups. This fits well not only for lifecycle assessment, but also for the cost analysis, which will be conducted in the next step. And so the first thing is I go through all of the IFC elements, filter the according cost group in my standard component database. And in the next step, I'm conducting a similarity analysis using natural language processing. So I'm basically looking at all the information we have. It could be also incomplete information. Maybe we have already some materials in the element, IFC element defined. If not, we can also use the description or the name of the IFC element. And we're using that to conduct, using natural language processing, a similarity according these names. One example would be from a case study I recently conducted was the IFC material name is Ortbeton, so that's the German general terminology for concrete on site. And but the LCA data set, which was then mapped, was already a very specific concrete type. How this natural language processing in the next step will look like is there are pre-trained NLP models. For example, I brought this example from Spacey, an open source NLP model. And so it's also machine learning or pre-trained model where every string or every expression represents a vector. And in the end, if I, for example, want to compare brick to terracotta, I can then do a cosinus similarity between both vectors and come up with a similarity factor, which is in this case 61%. And as we can see, when we compare brick to glass, the similarity ratio is much lower. So in this case, we know brick is closer to terracotta than to glass. And in the end, the workflow looks like that I'm going to compare all IFC materials with all LCA data sets in my standard component database and find for each IFC material or IFC element the LCA data set with the highest similarity. Now I'm coming to the end, discussion and future work. I want to extend my standard component database. One with more domain knowledge. One would be, for example, I want to go a step further in the component. Before the component, I also want to sum them up for different systems. For example, if it's different facade systems or different structural systems, if it's load-bearing exterior walls, or if it's a skeleton structural system. Then the next step would be also to extend it to construction costs. So I will add this also as external databases to my proposed framework, as well as I also want to include different LCA databases. What I excluded in my research so far was the embodied energy of HVAC and MVP, as it's usually excluded during to the norms still, and then of course do a visualization for design decision support. Thanks for your attention, and I'm open for questions now.
Okay, thank you for